Hello, my name is Faisal Abdul and I'll be presenting this presentation about Carbon, a coding language that Google launched as a successor to C++. Frustrated by the slow evolution of C++, Google decided to launch Carbon as an experimental open-source programming language that could be a successor to C++. Just as Microsoft built TypeScript to update JavaScript, Carbon could serve the same purpose, and it also offers an easy jumping-off point for developers to a newer language that addresses modern development concepts such as memory safety and generics. Google engineer Chandler Carruth introduced the language last week at the CPP North C++ conference in Toronto. Some may suggest that Rust, originally a Mozilla project that has since grown to have a significant public following, is a successor to C++, but Carruth says the opposite. While Rust is undeniably a great language to start a new project in, it doesn't have the same bidirectional interoperability of something like Java or Kotlin, making it difficult to steadily migrate. Moving a C++ ecosystem to Rust is hard, which is where Carbon comes in. Carbon has many of the same goals as Rust, but it is also intended to be fully interoperable with existing C++ code. Additionally, the goal is to make migrating from C++ to Carbon as easy as possible if desired by the user. Carruth shared quite a few highlights or features of the language on stage that might make a C++ developer want to consider introducing Carbon to their code base. Carbon features include introducer keywords and simple grammar. Function input parameters are read-only values. Pointers provide indirect access and mutation. Use expressions to name types. The package is the root namespace. Import APIs through their package name. Explicit object parameters declare methods. Single inheritance. Classes are final by default. Powerful definition-checked generics. And types of explicitly implemented interfaces. Why is Google moving from C++ to Carbon? Well, Google feels that memory safety is the lacking point of C++, and it also causes a lot of security threats. Carbon developers will be able to look for better methods to design idioms and APIs that build a comprehensive debugging build mode and support dynamic bound checks. Many developers are not completely pleased with what they have developed or designed, which is why many of them come up with new ideas that build upon their original creation, and which is also why Google is doing the same thing that Ryan Dahl did by developing Dino. What license is Carbon currently under? Carbon is currently under the Apache License v2 with the LLVM exceptions. LLVM is a super well-known set of compiler and toolchain technologies that can be used to develop a front-end for any programming language and a back-end for any instruction set architecture. Developers want Carbon to be released under a permissive open-source license. A project's programming language with compiler and runtime library considerations has the same essential demands for its licensing as the LLVM project, which is why the Apache license and the LLVM exceptions can be combined to solve this. Now we will take a look at comparisons between C++ and Carbon code. Google is planning to write the translation tool that migrates C++ code into a new Carbon language. And here on the right we see an example of C++ code. And now we'll be taking a look at the same C++ code but written in the Carbon language. And now as we take a look at the Carbon code, we can notice that it has become a little bit simpler and less cluttered. As mentioned earlier, Carruth disagrees with the people that think Rust is a successor to C++ because the memory safety needs and the performance of applications need improvement. Carbon, on the other hand, is for those who have vast codebase migration issues within C++. They face difficulties in migrating the code in Rust. That's where Carbon enters the picture. Information used for this presentation was taken from these websites. I hope this presentation was informative and thank you for listening.